I welcome you all to the Spark Research YouTube channel. This is Dr. Vishan, the Assistant Professor in the Department of ECE, and here is the another session of this series, Analog and Digital Communication. And in this session, we are going to take the questions which has been asked in GATE 2018, right? Particularly from the unit 1 and 2. So here is the syllabus for your GATE. So in this session, we are going to take the questions from this amplitude modulation and angle modulations, right? So here is the question. Question is, here is the amplitude modulated wave st is given, that is cos omega ct plus your 4 cos and then omega m and then cos of omega mt, right? So frequencies are given. So in this question asking the ratio of the power of the masses to carrier, right? So what is the power carries in the message signal and to the what is the power carries by the carrier signal? So that ratio only, right? So how can we find out? So we can use this equation, that is power is equal to amplitude square by 2, and power in massive signals we can use m square t by 2. So with the help of this equation we can find out. So answer should be lies in the range of the 0.12 to 0.13, right? So before going to talk about the questions, here is the some technical contents that you must know. So this is the amplitude modulation, that is a cos omega ct and plus mt cos omega ct. This part belongs to the carrier and this part belongs to the sideband, that is the masses, right? So power for carrier you can find out using this pc is equal to amplitude square by 2, and similarly power in masses you can find amplitude square by 2, that is m square 2 by 2, and then we can find out the ratio of power carried by the sideband divided by the carrier, right? So this is the simple technique. So let's see. So here if you will check, then the frequencies of your modulated wave is your 1200 for your carrier, and for LSB and USB, that is lower sideband and upper sideband, is 1000 and 1400, right? So we can find out, then the once we'll know the components, which one is carrier and which one is LSB and the USB, then it's easy to find out the power for the carrier and power for the sidebands. Okay, so let's find out. So here is the frequencies. So if you will see this 2400 pi is equal to twice pi f, then f will be 1200. So that is why the 1200 is your carrier frequency, and then sidebands, that is 2000 and 2800, both are belongs to the sideband, and you can find out the frequency with respect to the LSB, that is 1000 and 1400 for this USB, right? And the difference is FM is equal to 200, that is FC minus FM, right? And so sideband amplitude you can also find, that is mu and AC divided by 2 is equal to 1. If you will take it common, then you will get the value of mu, and the value of mu will be equal to the 0.5, right? And so you can find out the carrier power now. So carrier power is nothing, amplitude square by 2, that is this part belongs to the carrier and this part belongs to the lower sideband and this part belongs to the upper sideband. So carrier you can get the power 8 watt, and then masses power, that is equal to the am square by 2. So amplitude square by 2, so here am is equal to the 2, so you can get the value of 2 watt, and then ratio, that is pm by pc, that is 0.25, right? So now let's take one more question. So here question is, ct is given in this carrier wave, that is AC cos omega ct, and mt is also given cos omega mt. So it is given that fc is very much higher than 5 times of fm, right? The signal ct plus mt is applied to the input of non-linear device. Non-linear device whose output V0 is related to the input VIT, and V0 T is equal to A V1T and B V1 square T, right? Where A, B are the positive contents. The output of nonlinear device is passed through an ideal non-band pass filter with center frequency Fc and bandwidth is 3 of FM to produce an amplitude modulated AM wave, right? If it is desired to have the sideband power of AM to the half of the carrier power, then the ratio A and B, right? So this is question related to your amplitude modulation here, and message signal and carrier signals both are given, and the techniques it has been used, that is the non-linear type of the modulator technique has used, and then at the end of the modulation you are using some type of the filter and which will pass the signal. So the question is asking then what is the ratio of the sideband power to the half of the carrier power, right? So sideband to the carrier, actually whatever the carriers will find, we will make it half. So that is the question. So A by B, then the A by B is equal to what? If it is desired to have the sideband of the AM wave to the half of, right? So the this relation is given in between the sideband and half of the power, right? So both are equal, then the ratio of A by B. So we will find out the power in between the sideband and the carrier, and then we will get. Okay. So as per answer key, your answer D is correct. That is 2. So let's find out. So let's before solving this question, let's get the idea about the non-modulator. So this is the message signal, and here is the carrier wave, and this is the modulated wave. So we can perform the modulation by various techniques. Out of that, one of the technique is non-linear DSB-SC modulator. So here how is it working? Here MT is there, and omega cos omega ct, that is carrier wave, is there, and then xt, and the both are getting added, and non-linear device is there. We will get y1t and y22, and then it will add, and then we will pass it through the band pass filter. So finally you will get the 4 bm t and cos of omega ct. How is it? So yt will be axt plus bx square t. So here you will get the x1, here you will get the y1t, and here we will get the y2t. So once replace y1, yt is equal to y12, and once replace yt is equal to y2t. So then we will get the z of t, the difference in between y1 and y2. So that will be a x1t plus b bx1 square t, and then minus of, and once now we are replacing by y2t, then ax2t and plus bx2t, right? Now you can take the difference ax1 minus ax2t, and then the non-linear, this is the square term, both of you take the common. Then if you will solve this, then finally all things will cancel out, and you will get the 2am plus 4bmt and cos omega ct. So this will be the output, right? So the same tactics we are going to use it here. So here nonlinear devices will give you the output, and will use the band pass filter, and because of that we will get the particular bandwidth, and then we'll take the ratio of the power to signal divided by the PC, and then we will get the value of A by B, right? So the concept we are going to use. So let's talk about the final calculations. So VIT is given CT and plus of MT. So here, and V naught, this is the nonlinear devices. So let's get the value of the V naught T. So A, put the value of a VI. Already VI is given CT plus MT. So you will get the this first term and this second term, that is a square term, right? And then we'll get the difference. Already in the previous slide we have discussed that what will be the final, actually the output from this, right? So the whenever we'll pass it to the band pass filter centered at the fc, and having the bandwidth is 3 fm, so only it will pass the fc plus minus fm. The higher terms, that is twice by fm, it will already the it will reject it, means it will not pass. So the dc components fm twice fc terms produced function, so resulting wave, it will be your s of t a and AC, and 1 plus twice B by A and cos of omega m into cos of omega ct, right? So this is something like that, 4bm into cos of ct, that we all already seen. Now it's very easy to find out the carrier power and the total sideband, right? So here now with the help of this equation, now standard AM equation, right? So you can find out the amplitude power, that is amplitude square by 2, right? So finally the sideband power, that is this one, and divided by the carrier power, that is this one, put the values, and that will be equal to 1 by half 1 by 2, and that is why we can replace this in the question itself. It is given that is mu square by 2 is equal to 1 by half it will be. So you will get the value that is mu is equal to 1, and now you can substitute mu is equal to here. From here mu is equal to your twice of b by a, so a by b is equal to 1, right? So that's all in this session, and we'll take some more questions in our upcoming session. Thank you to join. If you have any doubts, please drop your comments.